My name is Sumi.
Hi.
Okay guys, today we are going to teach you how to apply matrices in solving linear equation systems.
Let's go!
Yay!
Okay, as mentioned earlier, today we are going to learn about system of linear equation using inverse matrix. But first, we need to know the methods to find the inverse matrix from a matrix equation AX equals to B form. We will have two methods in this case, which are adjoint method and elementary row operation.
Hello everyone. So for adjoint method, I will give you the overview of the process using adjoint method to find inverse matrix. So the steps are finding cofactor matrix, transpose the cofactor matrix, and then adjoint is obtained. So the next step are finding determinant and then multiply both determinant and adjoint. Therefore, inverse matrix is obtained. Jang jang jang. So this is the main character for today, which is our first question. So this system linear equation will be converted into matrix equation AX. Oh, hi Sokji, what are you doing here? Oh, never mind. So back to our lesson. The first step is forming matrix equation AX equals to B, and then multiply AX equals to B with A inverse. And we will obtain matrix equation X equals to A inverse B. Oh look, Kwangsu is dancing right there. So the next step is find cofactor matrix and then transpose it. So basically this is how... Hey swiper, no stealing. So basically this is how adjoint is obtained when we transpose the cofactor matrix. So the next step is find determinant, and then we will get the determinant -7. The next one is multiply determinant and adjoint matrix, and then at the end we will get the inverse matrix. So the very last step is the sleeping meow. Oops, no. I'm sorry. So the very last step is multiply A inverse with matrix B. Therefore, our equation is solved. So this is how we got the answer, which is x equals to 3, y equals to -2, and z equals to 1.
Wow, it's so cool, Yumi. Your explanation is very well. Now it's my turn. Before we go further, we must know how to apply ERO in our working. ERO includes the three operations, which are interchanging two rows, multiplying one row by non-zero scalar k, or adding one row with k times of another row. To make it clearer, here are a few examples. For the first operation, you can see there is an interchange between row 1 and row 3, where the first row will be the third row and the third row will be the first row. Next, for second operation, the second row is multiplied by 3, resulting to a change in value in second row. And lastly, for the third operation, the third row is changed by the addition of the third row and the first row that is multiplied by 2. Please remember that these are the only operations that we can use in ERO. I think you have understood it well. So now let's try one simple question together. Okay, here are three linear equations, which are 2x plus y minus 3z equals to 1, 3x minus y minus 4z equals to 7, and 5x plus 2y minus 6z equals to 5. So, how can we solve this by using inverse matrix method? Firstly, we transform the linear equations into augmented matrix form and use row operation for row 2 and row 3. Here, for row 2, 2r2 minus 3r1, while for row 3, 2r3 minus 5r1. Next up, we perform elementary row operations for row 1 and row 3 like we had done before, which are for row 1, 5r1 plus r2, and for row 3, 5r3 minus r2. Thirdly, we perform elementary row operations for row 1 and row 2, where row 1 plus row 3 for row 1 and for row 2 14R2 minus R3. Lastly, we perform elementary row operations for all rows to make all values other than 0 become 1. For R1, we multiply R1 with 1 over 10. For R2, we multiply R2 with negative 1 over 70. And for R3, we multiply R3 with 1 over 14. Now we can directly determine the value of x, y, and z, where x equals to 3, y equals to negative 2, and z equals to 1. Yay! Good job everyone! You did great!
Everyone, now let's pay attention to me. I am Sumi and I want to explain how we can use matrices in our daily life. Here is one situation. In this equation, it is stated that Ayuni bought ice creams with 5 cones of chocolate, 2 cones of vanilla, and 3 cones of strawberry for RM48. The next day, she decided to buy more ice cream for her students in UD and UA classes that worth RM67, and each of her students get a cone of ice cream with variety of flavors, as in 7 chocolate, 3 vanilla, and 4 strawberry flavors. Ayuni also bought a cone of chocolate ice cream, 2 cones of vanilla ice creams, and 3 cones of strawberry ice creams for her family. She paid for this ice cream for RM32. We need to determine the price for each cone for these 3 flavors by using elementary row operation. How we can do this? Don't worry, let me show you how to solve this problem step by step. First, we need to extract all the informations to come out with 3 linear equations with 3 variables as shown in step 1. After that, transform these equations into augmented matrix form. When we got the augmented matrix, we can now proceed to the next step. What can we do next? Well, let's use elementary row operations for row 2 and row 3, as in step 3. Then, use elementary row operations again, but this time for row 1 and row 3 in step 4. Repeat for another time by using elementary row operation for row 1 and row 2, as UL can see in step 5. Wow, we are going to reach the end of the process, guys. Hurry up. Lastly, use elementary row operation for row 1, row 2, and row 3. Ta-da! We can finally know the each value of x, y, and z. Each of these variables represent the each flavor for the ice cream. Fantastic, everyone. We did a great job.